All right, today we're talking about compound inequalities. We have and compound inequalities and or compound inequalities. Essentially, this is putting two inequalities together in some way. So a compound inequality is an inequality with two inequality signs, like I just said. So for an example, we've got -2 is less than x is less than 5. This would be like a little section of a graph that would look like this, with this on -2 and this on 5. On OR, we would have two equations here. So this would end up being a graph that looks like this, with a space in between them. OR means one or the other, and means both. So, intersection and is the overlap of an inequality. So this is essentially from 2 to 5. So let's go ahead and list that. We've got 0, 1, 2, 3, 4, 5, 6, 7. So we have an open dot on 2. I can tell because there's no underline on the inequality next to the 2. We have a filled in dot on 5. I can tell because there's a underline on the dot on 5. And we just want the stuff in the middle. Okay? So my interval notation here is going to be parenthesis 2, comma, and it has a line all the way until a closed dot, so that's a bracket at 5. All right? So let's take a look at this one. This says x is less than or equal to 1. So let's do 0, 1, 2, 3, 4, 6, 7. All right, so at 1, we're going to have a closed dot, and it's pointing to the left. So I'm going to make it point to the left, arrow forever. And then x is greater than 4. I'm going to have an open circle this time, and it's going to be pointing to the right forever. It's beautiful. So here, we have it pointing towards negative infinity. So we have a negative infinity, and then we have 1, and it's closed dot, so it's a bracket. Now, do you notice the space? The space in interval notation we're going to denote with a giant U. Okay? Then we need a parenthesis for our open dot at 4. It's going all the way to the right to positive infinity, and infinities always get a parenthesis. The only thing that ever gets brackets is that closed dot. All right, let's take a look at this. So now we need to solve. So in the middle, so now we've got 3 sides to our equation. We've got a left, a right, and a middle. It's very nice. Our goal is to get x all by itself. Right now it's x plus 3. So I want to subtract 3 from every single side. So on the left side I have -4. I have an x in the middle. And 5 minus 3 is 2. So I know that -4, then the inequality sign didn't change, so is less than x is less than or equal to 2. So mine's going to go from -4 to 2. So at 2 I'm going to have a closed dot. At -4 it's an open dot. Still. And then it's everything in the middle. So interval notation, we've got a parenthesis because of the open dot at -4. And then we're going to 2, and we have a bracket at 2 because it's a closed dot. So let's go ahead and try this again. We've got, again, 3 sides. This time we're going to be adding 2 to every single side to get rid of that -2. -6 plus 2 is -4. In the middle, all that's left is a 2y. And at the right, we're left with a 6. So now I need to divide everything by 2. And I have -2 on the left, a y in the middle, and a 3 on the right. And if you notice, my inequality signs have not changed at all. So it's -2 is less than y is less than 3. So now I can go ahead and graph it. So I have, let's see, -2, -1, 0, 1, 2, 3. So I have an open dot at -2, an open dot at 3. It's everything in between, which is a super easy interval notation because it's all parentheses. You've got a parenthesis, -2, comma, +3, parenthesis. There's our interval notation. All right, and we've got these two OR equations. And OR equations, I literally just treat it as two completely separate things. So we've got the one on the left and the one on the right. So we've got 3 plus x is less than -4. We're going to focus on that one first. So I'm going to subtract 3 from both sides. And I end up with x is less than -7. So I can go ahead and graph that because they're two separate things entirely. So I'm going to go to -7. We're just going to call that -7. It's going to be an open circle pointing to the left. So I can start that interval notation. It's a parenthesis, -∞, comma, -7, parenthesis. And on the right side, we've got to get that 3 to the other side, so we're going to subtract 3 from both sides. And I have x is greater than 4 minus 3 is 1. So that's right there. I'm going to put an open circle on 1. It's pointing to the right. And so that is a parenthesis 1 to +∞, close parenthesis. And because I have this space, I need to denote this space with a giant U. Without the little tail. It's just a U. All right, there was our first interval notation problem. All right, let's give this one a try. So I'm gonna have two completely separate problems. So here on the left, I'm going to add 5 to both sides. And I have 4m is less than -9 plus 5 is -4. I'm going to divide both sides by 4. And even though there's a negative, I don't flip the signs because I'm dividing both sides by a positive number. And I get m is less than -1. So we're going to make this -1. I'm going to put an open circle pointing to the left. It's at -1. So this is a parenthesis, -∞ because of the left pointing arrow. -1, close parenthesis. All right, and then over here, I'm going to add the 5 to both sides. And 7 plus 5 is 12. So then I would divide both sides by 4. Just messed it up. And that should be greater than. Divide both sides by 4. And I have m is greater than 3. So that's right here. It's still an open dot, and it's pointing to the right. Okay, so I'm going to do a U. I should really stop putting the tails on those. U. It's got a parenthesis. It's going from 3 to +∞. All right. You guys, I dare you to give these two a shot. You've got one and one or problem. So one should end up being a little segment. One should be arrows pointing in both directions. You've got this.